Hey, so this is an optional video to discuss regression matching. Hold on a second, I didn't open my notebook. Ugh. Lovely ceiling fan in my bedroom. So this is the worksheet, the regression matching worksheet. This is for anyone that wants an explanation on how I got the answers that I got. So I asked you to fill out a survey. And after you filled that out, if you found that you were getting a lot of wrong answers, that this is the video for you. If you clicked on this and it turns out you actually got a lot of right answers on that worksheet, then don't even worry about it. Click off. You don't even need to be here. Okay, so here is my video, or here's my worksheet. Okay, so this is one of those trial and error type of matching games. So I'm going to start off with the R values. So table A has the R values. So I'm going to start here. And I notice that I have 3 negatives and 2 positives. So just looking at these graphs, I'm going to do all of table A in one color and all of table B in a different color because I'm going to be writing all of the graphs. But just looking at R's, positive R's go up, like the slopes go up, and negative R's go down, like the slopes go down. So I'm just going to look at these graphs, and I notice this one goes up, and this one goes up, and this one goes down, and this one goes down, and this one goes down. So that tells me where to start. So let's just start with the positives because there's only 2. It should be easier to narrow these 2 down. But what I have here is I don't want to use that underline because the underline looks suspiciously like a negative. I'll just do little arrows. Those 2 right there are the 2 positives, and one of them is 0.88, which is pretty close to 1. I'll just put that right here. Close to 1, which is telling me that that is stronger than 0.45, which is in the middle. It's not super close to 0, but it's not close to 1 either. So this one, close to 1, means it's going to be stronger than, stronger? Let me just shove a little n in there. Stronger than the 0.45. So going back up to A and B, looking at those 2 pictures, which one is stronger? Which dots are closer to the line. So I can see on B, these dots are pretty close to that line, whereas on A, they're a lot more spread apart. So B is going to be the 0.88, and A is going to be the 0.45 because that's the only other positive. So really, I'm just looking at 2 pictures, and I'm saying which picture is stronger. That's going to be the bigger number. And graph A is left over, so it has to go with 4,5, which is the leftover number. Okay, so now we're going to look at the negatives. And I'm going to take off some of this writing for my next pictures that I'm going to draw. But looking at the negatives, that means we're looking at C, D, and E. And so again, I want to look at what's closer to 1. So this we said was closer to 1. This guy is closer to -1. Of the 3 choices that we're looking at, negative 0.95, that's practically -1. So that picture is practically a straight line. So of C, D, and E, C is practically a straight line. The negative means it goes down. So yeah, I confirm that on the graph, it goes down, and the 0.95 means it's practically a straight line. So now with my matching, I really only have 2 choices left. They're both negative. Graph D and E are my last 2 graphs. And I just have to look at the 2 numbers. So these are, so when we did the A and B graphs, I have 0.73. These are both negative, so I'm not going to say negative every single time, just looking at the absolute value. The 0.73 and the 0.45, which one is closer to a straight line? Well, the answer is always which one's closer to 1 or -1. So this guy, 0.73, the negative 0.73, that's going to be closer to a straight line than this guy, the 0.45. So looking at the 2 I have left, which one of these 2 is closer to a straight line? This one? Yes. I agree. Whereas this one is pretty messy. It's kind of jumping all over the place. The dots are not as close to the line. So on the scale of straight lines, C is the closest to a straight line. E is in the middle. It's like Goldilocks. C is just right. E is in the middle, and then D is the farthest. It's the most scattered. So it's going to be the number that's more towards 0 of the choices. Now, is that close to 0? Negative 0.54. It's not even halfway to 0. However, of the 3 choices, it's the closest to 0. So those are the R answers. Now, we're going to look at table B, which is looking at slope and y-intercept. And so just like table A, some of these pictures are going to be easier to figure out than others, and we'll just narrow down the harder ones. So looking at slope, well, slope and R have the same sign. So positive, so this is, we're looking at A and B in this picture. Okay, so slope, positive. This line goes down, this line goes down, this line goes down. So R and slope are not the same number, but they are the same sign. I'm going to write that. That sounds like a big deal. R All right, so it looks like my last, oh, my head is really big. Ooh, looks like the last video was cut off because my internet cut off. Yay. However, we're back. So this video, this little video will be about table B. So here we have table B. So I'll have to go back and watch later as to where the video actually shut off, but I want to make sure that you have this sentence. R and slope are not the same number, but they are the same sign. So we're looking at this new equation, or this new format for this particular problem. It's using y hat equals b plus ax. Why? I don't know. It just is. It's okay. It can use that. We have, the reason I know it's written this way is because the x's are at the end. So that's fine. Sometimes sometimes equations are written that way. Sometimes they're written with the slope in front. As long as you remember that the y-intercept, the b, is the one by itself, and the slope, the a, is the one with the x. Okay, so again, I'm going to start with the positives because there's 2. So it'll be easier to, hopefully easier to narrow down. Maybe not. I don't know. We'll give it a try though. Okay, so here I have this guy and this guy. Those are the, I'll write it like I did before. Those are the positive slopes. And then negative slope, negative slope, negative slope. So I'm looking at the first and third equations, and I'm comparing them to graph A and B. So looking at these 2 equations, I notice they have the same y-intercept, so that does not help me in this problem. I can't narrow it down that way, but they have different slopes. And so what I'm going to have to do is I'm going to have to find the graph that's easiest for me to read and make some guesses on. And I will calculate the slope the old-fashioned way. So I'm going to look at B. I'm going to zoom it in like super far so I can get as much detail as I can out of this graph. But ignore the dots. we are only talking about the line. And it looks like right here, the line crosses, or that's a point on the line. And right here, and I'm trying to pick points that are easy for me to label. Like this point, I don't know what that is. It's 15 something. Maybe it's 1530. I don't know. I can't tell for certain. It could be 28, it could be 32. But this point right here looks pretty much like, I'm going to zoom back out, otherwise my writing is going to be ginormous. This looks like the point 2040. X coordinate, Y coordinate. And then this other point looks like the point 35 with a height of 80. So what I'm going to do is I'm going to make a slope triangle, and there's lots of ways to calculate the slope. Whatever you remember from algebra is the way you should do it. But I'm just going to draw a slope triangle because that's the easiest picture way to do it. And so I'm going to start with the left dot, and in this case, I'm going to go up, and it's supposed to be a dashed line, but my tablet doesn't really like dashes very much. All right, up and over. Well, now it just looks sad. I could at least draw a straight line. Up and over. That makes a right triangle. This is a slope triangle. And so I can count from 40, because that's where I am here, from 40 to 80, how far up did I go? I went up 40 spaces. Don't say 2 spaces because there's 2 boxes. I want to know the actual amount of space we went up. The reason you can't say 2 is because a box this direction goes by 20s, but a box this direction goes by 5s. So since they're not the same scale, we can't use that. We have to use actual numbers. So I went up by 40. And then I went over from 20 to 35. So I went over 15. So the slope of this line, this is going to be approximate. It's not going to be exact, but the slope of this line is 40 over 15. Rise over run. The slope of this line is 40 over 15. And when I put that in my calculator, I get about 2.6. Now, I don't expect this to match perfectly an answer on this because I did a lot of guessing, and I tried my best to get, it's definitely an educated guess, but it is still a guess, so it's not going to be perfect. But what I did was I found that the slope was, a little over 2. So I look at my 2 choices from too zoomed in. I look at my 2 choices from table B, and I say which slope is closer to a little over 2, and that would be this first equation right there, because this slope is 2 and this slope is 1.1, and so 2 is closer to my estimate of 2.6. The reason I chose that graph was because even though it wasn't perfect, I was able to plot those 2 red dots and get a pretty good estimate of where they were. On this graph, it's a lot harder because these dots don't really seem to be going through the crosshairs. It's gonna be a lot harder. It's gonna be a lot more of an estimate for me to use those 2 points right there because I'm not really sure what the Y value is on those 2 points. So that's why I used graph B. But the nice thing is I don't need to do this again because I only had 2 choices. I only had 2 positives. A and B were positive. I said the first equation was B. So that means by process of elimination, that guy has to be A. And that's what this worksheet's about, is about using what you know about these graphs, about the R, the strength of the linear correlation, as well as the line itself, y equals mx plus b, or y equals ax plus b, in order to make your best guess about these graphs. Okay, so we are down to our final set here. We have 3 negatives and we have 3 graphs. Now, first of all, y-intercept is the easiest way to tell. So, boom, boom, uh-oh. I just shrunk mine. I don't know if I shrunk it on yours. Hopefully you can still see it. All right, y-intercept, y-intercept, y-intercept. I noticed this one is different than the other two are both 80. That one's 62. So I'm going to look at my graph and I'm going to find which ones are 80 and which one is 62. And then I'll be done with the next problem. So looking, that one is clearly 80, clearly 80, clearly not 80. 62 looks like a perfect estimate for graph E. So here I have graph E done. And that makes it a lot easier because now I have 2 left. Whenever I have 3, that's too many. So I want to try to get one away quickly. And now I have 2 graphs left, which is C and D. Weren't we stuck with those 2 last time? C and D. And then I need to narrow down the difference between these 2, which is the slope. One of them is closer to -1 and one of them is closer to 0. So I'm going to pick a graph. I'm looking at C and D, and which one seems to go through some points a little more obvious, not obviously, but a little more clearly. And I like D. I already have my dot up here at 80. And it looks like this is pretty close right here. Or even this one looks pretty close. So something that's pretty close to something that I can guess. So I'm going to estimate this point right here as 8. Oops, I need to zoom out again because my writing gets too big when I'm zoomed in. I'm going to guess that point right there as 80, 65. And then this point, it's actually not a guess. I know the point 0, 80 is on this line because it's the y-intercept. So that's a for sure right there. Okay. So slope triangle. I'm kind of mixing my colors up, but that's okay. The Christmas ones are table B, and the blue ones, what's that, Hanukkah? Oh, perfect. Hanukkah is A, Christmas is B. And yeah, it's Easter, so who knows what's going on in my holidays. Okay, so this one we're going down. Oh yeah, I can't do dashed line, so I'll do a solid line. I'm going down, and I'm going over. So how far down did I go? I went from 80 to 65. 80 minus 65, that's 15, but I'm going down, so it's -15. Okay. How far over did I go? I started at 0, I went over to 80. I'm going over positive. I started here and I added 80 to it, so that's a positive 80. I went to the right. So I have my slope, M. Well, I'm calling it M. It's A, but the algebra teacher in me still calls it M. All right, so rise, you went down 15, over run. Now I can just make a guess right here. Is this closer to 0 or closer to 1? Well, it looks like it's going to be closer to 0 because that numerator is so small. But we can plug this into our calculators, -15 divided by 80, just to confirm. This is actually a pretty good guess. Rounding significantly, I got -2/10. Oh my goodness, that's what I was aiming for, -2/10. Look at how brilliant I am. Perfect. Now, okay, yes, I'm brilliant, but what's really happening, the reason I was able to get it so close is I was a lot more accurate in this problem. That y-intercept, that 0, 80, that was spot on. We knew that point was there. So the more accurate we're able to get with our points, the more accurate, the closer to the actual slope our answers will be. So turns out that graph D was, oopsies, give me my green. Graph D, what is going on? I clicked on green twice now. Boop. Click, click. Okay, super green. Why does it matter? I don't know, because I have nothing else to worry about in my life than how pretty my paper is. So there we go. I have green D. And then only one choice left. I do not need to calculate the slope because I only have one choice left, and that must be C. So those are the final answers. Go back and rewatch any of these problems that was giving you grief until you understand it. And don't forget what I wrote in black at the bottom. R and slope are not the same number, but they are the same sign. Okay, so let's see here. Let's go back to my Oh, what's that? My name? Oh, too close again. All right, I don't know if I'm in the middle. I don't even care anymore. I will see you in the next video.